Hi guys, the Houdini digital set I'll introduce is SmartScatter. I'm going to share why I decided to develop this set, goal, process, what kind of ideas were applied, and where this can be used. First of all, this is how I felt when I use existing scatter sets. The common dilemma is render time and memory is increased with scatter numbers, and we lose shade at the edge of trees when it's too much. Also, there is the tendency of scatter if the set doesn't support solutions such as relax. The last, when there are collide and the camera is moving, there is flickering at collision part, so it's needed to back GI before final rendering. For example, when it's collide, we can remove collided geometries, but then we have more empty space as much as they are removed. To some, when it's more, we have more problems too. The goal was to reduce time, including working and rendering time both, so we get more productive result. In a word, the goal was these three keywords, named SmartScatter. I shared the development progress and features. If you like to fill this empty space with full of trees, mostly we typed count number manually. If we want to create similar 100 results on different grounds, we need to change the tree numbers whenever we scatter. If we know proper number for each case, then we don't need to do it manually. To know that, we need three elements: position, scale, and distance. For instance, if we calculate how many muffins can be in this box, the first way is to measure muffin and box size, then calculate it. The second method I thought was we figure out the approximate numbers in the first method and pour them a bit more muffins into the box, then count only remains in the box. It can be useful when it's difficult to calculate because of the different sizes. Now we're back to trees. If we can predict the appropriate number for each cases, then we can convert the number to a percentage. If we can control them in percentage, then we can control how much density you want to scatter. If the ground size is changed or the shape is changed, but we still maintain a constant density as the shape changes, and this is the basic concept of this set. Now let's see how to plant when we actually plant trees. How much density, spacing, and pattern. The bigger rootstock, which is used when planting more than 4 meters of trees, has the same rules as shown on the right. This is schematized result of the planting. You can see that the muffin box you saw earlier is almost the same way. I used Pythagorean theorem, proportionality, and proportional distribution to get the right distance, using the ratio of the radius of the circle to the maximum distance to the other circles is 7 and 3. You can adjust the distance between the geometry. Then we can remove the empty space from each other. This is the distance density test to radius. If you look from the right to the left, you can hardly see blue ground from 70%. Shading of edge of the object can be up to 30% lost, but this is not a problem for tree shapes. This result can be used directly in the existing scatter assets. And then the second method, you pick up twice as many as you need and you pour it into the box. If we move them to keep each other's diameter, and then we remove muffins out of the box, you see they don't overlap or collide anymore with each other. It's clear at wireframe mode. This simulation mode is the one, and other one is to calculate proper numbers without simulation. This count mode is faster but less accurate when geometries have various sizes. When it's filled with different sizes geometries, simulation method is taking longer, but results are more accurate, precise, dense. Initially set a bit more values than we need. The number decreases as you simulate. It's getting closer to the optimized value. As you can see, both methods have a basic setup to automatically get the right number without typing the number manually. Of course, you can manually type the number directly like other scalar assets. You can also adjust the ratio as a percentage of the area. In the process of simulation, the scalar shape is naturally determined, so the scalar pattern problem is solved. Even in counting mode without simulation, you can adjust the relaxed iteration to control how much tendency you have. Here is what I've been taking about so far. With measures up, you can easily get the area regardless of the shape of the ground. Then measure the size of muffin. Find the average length of one side of the box. Find the number of muffin on one side, using POW to find the total number, and then percentage it so that you can control the number by percent, and add it to control the numbers manually. And I've added a padding value to the muffin size. If you don't want to stick them together completely and want to keep them at a constant distance from each other, you can give them a padding value to determine how far apart they are. Next, I had to set up to avoid overlapping the geometry, and this is some of the methods I tried. This is an algorithm called circle packing, which allows you to specify the maximum and minimum size and to increase the size of the point just before collision point. This way is to fill a circle inside the face. This way is to locate at the point of triangulated surface and fill. The first thing I've tried was to get the radius of the surrounding circles and the distance to each other and move the red circles only as long as they overlap each other. But when this happens, the red circle overlaps the white circle on the other side. Fortunately, there were similar features in Houdini. If you use relaxed iteration, if makes the distance as close to each other as possible, but there are limitations when the scale values are vary. Next, there is a pop node called interact. It takes a long simulation time, and even though I did set up to stop moving when there are no more collisions, but they still moved, so I had to lock them at a specific frame. The next is grain node. It uses much less frames on simulation, and when there is no collision, it was a lot easier to stop velocity immediately, so the result was very accurate. The left one is interact node in new pop. The right one is grain, and basically it's similar. They find the near points and subtract the radius from the distance between the 2 points. The difference is grain has a lot more attribute, so it's easier to control, and it calculates 3 times per frame, so it's more accurate. Most of all, it stopped very well when there was no collisions anymore, so I could save time a lot. This is a comparison of promotion method of p-scale values. To find out how many muffins are in the box, you need to know the size of muffins. If the sizes are different from each other, like this graph, you need to set one number. If you have 5 numbers, 1, 2, 4, 8, and 16, adding all of these numbers and dividing them by 5, and you get a 6.2 average. If it's median, it's going to be in the middle of all numbers, so you will get 4. If we find the root mean squared, we get about 8.3. Root mean square can be very useful when you want to reduce the weight of very high or low peak values when they are much higher than the average value. In FX, you can use it to find average velocity value or average the negative velocity as shown in the sine-cosine graph. In simulation mode, I set the number of objects in the space more than twice the area, so I used root mean square to reduce the deviation as much as possible. The average seems more appropriate than the root mean square in count mode, because if the overall number decreases because of one large geometry, there will be more gaps. The next feature is smart selection. Sometimes scatter doesn't work if the number of polygons in the ground geometry. In this case, you need to add more polygons. If you select the smart selection here, you can scatter directly without adjustment. And this is auto pivot, where the axes of the source are different. So if you scatter and they are in a different height or position, if you turn on this, whatever the axis of the original geometry was, it will set the axis to center down. This is auto resize. When scatter, the scale parameter is usually in percent, so if the source size is different, scaling in scatter set will still be different. So I used to set up scale manually before scatter. In this case, as opposed to count numbers, I changed the previous scatter scale to an absolute value. So if you type 10, it will be fixed at 10 meters, regardless of its original size. For example, the residential area is regulated between 12 and 15 meters according to the building code. In this case, auto resize makes it easy to modify to the desired height, regardless of the original geometry size. This is scale ramp. Let's say we say scale ranges from 70% to 100%. We have 4 geometries, then it will be distributed at constant rate, such as 70, 80, 90, and 100. You can adjust the range of distributed scale non-linearly. For example, here's a picture of coffee bubble. And most of the bubble sizes are very small, and the ratio of large bubble is very low. You can use the scale ramp to change the distribution ratio. Next is edge offset. This is similar to border distance menu on a common scatter set. Use it when you want to scatter more or less than outer boundary. Next is auto rotation. Degree unit is used. Like a scale ramp, rotation can be scaled non-linearly. With normal, you can unify them upward, flip, or follow the direction of the ground. And this is normal blend, which allows you to mix the normal direction of the ground with the default normal. It is suitable to scatter, such as arrows or grass, that match the slope of the ground. Finding the closest floor from scatter, then gets the angle, normalizes, applies the normal direction as the axis, then the rotation remains the same and only normal direction changes. And about blend, divides the axis into up and floor vectors. Added 2 vectors, then adjust normal blend parameter to determine which vector is higher. Next is camera frustum. It's also called camera adaptation or camera clipping, which scatters only inside the camera range. When auto mode is selected, it even saves the geometries around the camera boundaries. At the camera view, you see the geometries across this red square border are all live. Manual mode is an option that can be determined by adjusting the XY axis manually. You can also specify how close or how far you want scatter to be by using Z-depths. You can save only the outside of camera. This is weight ratio. You can assign IDs to scatter as many times as you want and how much weight each ID has. Finally, this is preview. You can show or hide the geometry as bounding box, and also use the point cloud option if the original geometry has point cloud information. As I add features, the menu becomes more complex. So the basic UI is as simple as possible, but you can expand the menu only you want to use. I removed some parameters, the less used menu. Next is optimization. I've implemented to adjust the size or angle of geometries without using copy stamp. The speed of scatter is about 800 times faster. This is the comparison of features used to erase geometries from Houdini. Blot stop was approximately 20% to 200% faster than remove points function or delete stop, if only the points which have specific condition. I customized ray setup so it's up to 20% faster than default ray. Some in this subset, scatter process is automated. It provides detailed functions when modifying them manually. And the same functions have been selected to produce the most accurate and optimized results. This is height field scatter. I set up not collide each other as much as possible. Both, it's okay in the middle, but it's a bit different at the end grounded. Height field is being updated, so it might be different now. Here's an example of making bubbles of coffee you saw earlier. Set the shape, bubble position. And scale ramp is used to scale bubbles non-linearly, as shown on the left. Adjust the distance so that the bubbles stick to each other a little bit. I use dirt shader for bubbles. The next is trees. The distance is adjusted so that the trees are separated from each other. If you adjust the distance in the actual camera view, you can set up more accurately. If the camera angle is high, it's better to attach more. If it's low, the ground will not be visible even if the distance is further. You can adjust the ratio of specific tree among them. Next is mountain. First I created a height field and use whirly noise. Give trees a moderate distance. Sets the size between 4 and 7 meter. Randomly rotated. Reduce trees number using camera frustum. Next is flowers and grass. Set the distance. You can either increase the density in percent or the number manually. Uses frustum. And only the inside of the camera remains. Frustum is only applied to grass, so the flowers are outside from camera. Also, the algorithm is similar to whirly noise or Voronoi, so you can use this set as whirly noise. It's also called cell noise. The difference is that you can adjust the size and distance of the cells. and use them directly as mesh instead of using it as normal or displacement map. For example, molten lava, or it can also be used to create textures as meshes, or for chicken skin. Next is color brightness test. I create the circle at first. Since the scatter ground and the geometry to be scattered are both circles, connect these circles to both sides of the set and turn on auto resize to make it smaller than the original. Then simulate them. They push each other. However, they should be separated like the picture on the left. So I set padding for it. And now we have hole shapes. Next is number. I used the font stop, wrote $F to get the number of each frame. I set the scale and position. Used group stop to choose the points in the shape of numbers. One side leaves only numbers and other side remove only numbers. And give each point a random value between 0 and 1 and name it random color. Then apply a random color attribute to the color ramp, and one of the colors in the ramp range is randomly placed in each circle. I set different colors and connect all of them to the lower switch subs to randomly output one of them for each frame. Likewise, copy colors and switch subs to the background, then press Shift R on the switch node to send red to the back, starting with orange and ending with red. Then even if both switch nodes are equal to 0, the numbers are red on the number side and orange on the background side, so that the same color does not appear at the same time. You see, now we get different results per every frame. If your goal is to create one image, it's much faster to work with Photoshop. But if your goal is to create thousands of images, procedural setup is more efficient and results are consistent. In this way, it's easy to create patterns of designs that keep a constant distance from each other. Likewise, you can easily create patterns similar to these pictures. This dot painting style will be similar to the original picture when we give different colors one by one. In fact, there was no big difference from the original picture. You can give variations like any other pictures. The first, the module and package comparison. If we divide them into modules, one node per function, the scope of use will be wider. Even if it's not necessary to scatter, you may only want to use auto pivot or assign multiple IDs to an existing scatter. It will be more difficult to use, but there are more advantages of the module type in terms of utilization. Finally, Houdini engine. A simple test on Maya works very well in real time. in Unreal, it wasn't real time, but good enough for practical use. That's it for this video. Thanks so much.